What's up, guys? It's Talha here again today, and today what we are going to do is we are going to start from where we left off yesterday. Not yesterday, the day before yesterday, and I accidentally deleted the video from my laptop, so I wasn't able to post it on YouTube. But today I'm going to start from where I left off in that video. So in that video I left off on question number 30 of exercise 3.2, and in this video what we are going to do is we are going to start from question number 31, or the part where it says find the first and second derivatives of the function exercise 31 to 38. So what we are going to do is pick our part number 31st, that is y equals x cube plus 7 divided by x. So what they are asking us in this question is to find the first and second derivative of this function. So first we are going to do is find the first derivative. So d by dx of y equals d by dx of x cube plus 7 divided by x. So here we know that we have to use our quotient rule. So y derivative equals our quotient rule is second derivative of first, I mean the denominator derivative of nominator, numerator, and then minus numerator derivative of denominator, x divided by denominator whole square. So this is our quotient rule. So if we solve this for the derivative of y, so we are going to get x, and derivative of x cubed plus 7 is 3x, minus x plus 7 into derivative of x is 1 divided by x squared. And if we solve this further, we are going to get 3x squared minus, so x plus 7, because it's into 1, so it's going to be the same, divided by x squared, and y derivative is equal to so y derivative is equal to 3x squared minus x plus 7 divided by x squared. Now if we find the second derivative of this, so that means we are going to find the derivative of the derivative of y. So that is going to be equal to y double derivative is going to be, so if we find derivative, I'm just going to do it directly. So if we find derivative of this, we are again going to have to use the quotient rule. So denominator derivative of numerator, which is 3x squared minus x plus 7, and then again minus numerator, that is 3x squared, oh sorry, this is x cube, this is x cube, so here this is x cube, so 3x 3 this is 3x squared, the derivative of x cube is 3x squared, and minus 3x squared minus x cube. So the derivative of, so the minus x cube plus 7 into 1, and this is 3x squared, so this will be 3x squared, 3x cube, because it's x and x squared, so 3x cube minus x cube plus 7. So this term is actually going to be, so the derivative of y is actually going to be equal to 3x cube minus x cube is 2x cube plus 7 divided by x squared. So that is actually the derivative of the function. So now here, this is not, I just, you make a lot of mistakes while doing the question, so you have got to, and you should do you should practice on some questions, because that way, on this is the only way you're going to find out the mistakes you will do in the questions in the future or in the paper exam. So instead of, it's better to commit mistakes here than in the exam. So that's why you should always practice these questions before appearing in exam. So you have the derivative of this is going to, so we are again going to apply the quotient rule. So you have x squared into the derivative of d by dx of 2x cubed plus 7 minus 2x cubed plus 7 minus 2x cubed plus 7 into derivative of uh, x squared and divide by x square whole square. So the derivative of this is going to be equal to x square, and the derivative of this term is going to be equal to into 3 into 2 is 6x square plus 0, so that will be equal to 0, and minus 2x cubed plus 7 into derivative of x squared, that is 2x divided by an x squared. So whenever you have a variable and that has an exponent, and you have the power of, and you take square of the whole thing, the variable and the exponent. So what happens is the exponent gets multiplied by the power. So you have x, and 2 multiplied by 2 is 4. So y double derivative is equal to 6x squared. So 6 x to the x squared into x squared x power 4 minus 2x into 2x cubed minus, so that will be equal to so this is actually minus x cubed minus 7, so it's 2x cubed minus 7, sorry. So this is, see how many mistakes I'm committing today. It's because I just came home, I was out with my friends, and I'm kind of tired. That is why I'm committing so many mistakes. So you have minus here, so 2x cubed minus 0, so that does not matter because this becomes 0, minus 2x cubed minus 7. So yeah, so that's equal to 2x cubed. So 2 into 2x is 4x power 4 minus 2 into 7 is 14x, and divide by x power 4. What we do, we open the brackets. You have 6x power 4 minus 4x power 4, minus into minus plus no, plus 14. So this is minus, so you multiply the whole term by you multiply the whole expression by minus. So plus 14x divided by excuse me divided by x power 4. So what you get is 6x x power 4 minus 4x power 4 is 2x power 4 plus 14x divided by x power 4. You take x common, so you actually take 2x common, so that will be equal to 2x cubed plus 2 7s are 14, and x, no, or you take if you take just if you take just x common, because we want to cancel out this x with this. So if you take just x common, you will be going to be left with 2x cubed plus 14 divided by x power 4. So this will be cut, the power will be cut by 1. So you are going to get y double derivative is equal to 2x cubed plus 14, yes, plus 14 divided by x cubed. So this right here is the double derivative of the function y equals x cubed plus 7. So this is the first derivative, this right here is the first derivative, and this right here is the second derivative of this function. Alright, so now what we are going to this, and you have 5 more questions, or sorry, 5 6 you have 7 more questions. You can do these questions by yourself. I want to leave some of the stuff up to you guys, so you guys can take care of that, because I want you guys to practice as well. Next we are going to do using numerical values. So we have a question number 39 is, suppose u and v are functions of x that are differentiable at x equals 0, and that, so 39 question says, suppose u and v are functions of x and are differentiable at x equals 0, and that u of 0 means u is a function of x and u of 0 equals 5. Derivative of 0 is equal to -3. V of 0 is equal to -1, and v derivative of 0 is equal to 2. So what they want us to do is to find the values of the following derivatives at x equals 0. So they want to find they want us to find the value of the derivative d by dx of a, that is u of v. So here we know that here this is the multiplication of two functions. So what we are going to do is use the product rule, that is first derivative of second, so d by dx of second plus second derivative of first derivative of u. So this is equal to u and v dash, and u and v dash plus v and u dash. So they want us to find the derivative of this function at x equals 0. So what we are going to do is the u of 0 into v dash of 0 plus v of 0 into u dash of 0. So what you are going to do is just put the values. So u of 0 is 5, and v dash of 0 means derivative of v. The derivative of v of 0 is 2, plus the v of 0 is -1, into the derivative of u. Derivative of 0 of u is -3. So this is equal to 10 plus minus into minus plus 3. 10 plus 3, this is 13. So this is the derivative of u into v when you have these terms given. Now you have 3 more questions, and you can do those questions by yourself as well. You have question number 40. Suppose u and v are differentiable functions. Also, let me just do the D number question. That's kind of a tricky question. So d by dx 7v minus 2u. So this is the question. So what we are going to do is to solve this by taking the derivative of first. It's subtraction. They are being subtracted. So d by dx of 7v, right? Right. 7v minus d by dx of 2u. So that means that so we are taking the derivative with respect to x, so that will be equal to 7, and v derivative minus 2, and x derivative, and we are finding derivative at point 0. So 7 and v dash of 0. minus 2 and sorry, u dash of 0. So 7 v dash of 0 is minus 1. 7 into minus 1 minus 2 into u dash of 0 means u derivative of 0 is minus 3. So minus 7 and minus 7 minus into minus plus 6, that is equal to minus 1. So there you go, you have minus 1. And then we have another question that is just like this one. We have suppose u and v are differentiable functions of x and that. Alright, I'm just going to do a question from this. So you have suppose, so they told us that suppose you have no, alright, so these the next question is just like this question. You're just, the difference is that here, here x was different here when x equals to 0, and all of these the functions were at that point and you had the values given. The difference is here the x was differentiable at 0, and then the next question x will be equal to 1, x is equal to 1. So the only difference is you'll have to find the value, you'll have to plot the values of where the function of 1 was equal to, and you had to plot those values instead of instead of plotting these values. So the difference is only this one. So the next is slopes and tangents. So normal to a curve, find an equation for the line to this. Alright, so here slopes, so the next part is slopes and tangents, and here it's given that normal to a curve, and here we are given find an equation for the line perpendicular to the tangent to the curve. So first, so we have to find an equation for the line perpendicular to the tangent to the curve. So for example, this is a curve and this is, for example, the tangent, means the slope, and so this is the curve of y equals x cubed minus 4x plus 1, and at point, and at this point is 2 and 1, and then find an equation for the line perpendicular to the tangent. So we have to find the line, find the equation of the line that is perpendicular to the tangent to this curve of y equals this at point 2, 1. So we have to find the equation of this line. So here what we are going to do is first, we are going to find the derivative of this equation. So that will be equal to finding the derivative means finding the slope or finding the tangent of this curve. So that will be equal to y derivative. So when we find the derivative of this, so y dash is equal to 3x minus 4. So the derivative of this is 3x minus 4, and now what they want us to do is they want us to find the equation of tangent at, what they want us to do is to find the equation of tangent at points 2 and 1. So x is 2 and y is 1. So slope of tangent at 2, 1 is so so the slope of tangent line, so the slope is this, but they want to find, but the point is at this point exists at point 2, 1. So that means that here we are going to plot x. So So when we will plot x, so that is just the derivative, and we are going to find we are going to plot the value of x just like here in the derivative of the equation, that is the slope of the equation. So y derivative equals 3 into 2 for x minus 4. So y derivative equals 3 into 2 is 6. 3 into 2 is this is 3x squared. So 3 into 2 squared, so 2 squared is 4, 3 4s are 12, minus 4 is 8. But here's the tricky part. We have to find an equation of this line, and we know whenever the lines are perpendicular to each other, that is a normal, and the relation between the slopes of two perpendicular lines means that, when a line is perpendicular to another one, the slope of one line will be the reciprocal of the slope of the second. So means like if this slope has this tangent line has a slope of m1, this line is going to have a slope of minus 1 divided by the negative reciprocal of the first slope, so minus 1. So whenever two lines are perpendicular, the slope of one line if you have the given slope of one line, the slope of the second line will be the negative reciprocal of the first slope. So here, these two lines are perpendicular, so what we are going to do is take the negative reciprocal of this, so this will be equal to minus 1 by 8, and this right here will be the slope of this right here of this line. So what we can do is just plot all of these, just put all of these points in the equation of the line, that is y through point slope form. So you have y minus y1 equals m into x minus x1. So this is your point slope form. So what you're going to do is just plot the point. So y minus, what is y1? y1 is 1 equals m, that is minus 1 by 8 into x minus x1. So x minus x1 is x1 is 2. So y minus 1 equals minus x by 8, and plus minus into minus plus 2 by 8 is 1 by 4, and here if you shift 1 there, so x by 8 plus 1 by 4 minus here there, so plus 1. So this right here is the equation of this line. Alright guys, I'm out of time. Thank you very much.